this tutorial, you will learn how to simulate an antenna. As a typical example for an antenna, you will analyze a square resonator. Once you've started the software, you need to click on the New Project in the File menu, and a dialog box will appear. Now give an appropriate name for the new project, in this case square resonator. Set the proper units and press OK. The next step is usually to set the material properties. Open the new material dialog box and define a new material name. Afterwards, specify the material properties in the epsilon and mu fields. Once you've done that, you need to choose a color for the material and then press OK. The first construction step for modeling a planar structure is usually to define the substrate layer. This can be easily achieved by creating a brick made of the substrate's material in the box geometry section. The material setting of the brick must be changed to the desired substrate material. You need to provide the values for x1, y1, z1. Once you've provided all these values, you just need to press the OK button. The next step is to model the square resonator on top of the substrate. Therefore, go to the geometry, select patch, and then a patch geometry dialog box will open. The material setting for the brick must be changed to the desired square resonator material. Because no material has yet been defined for the square resonator, you need to select the PEC as the material from the material drop-down list. You need to provide the values for x1, y1, length x, length y, and z. Once you've done this, you need to repeat this procedure 3 more times. Now again, select the patch geometry section. Provide a name. Provide the value for x1, value for y1, length x, length y, z, keep the material as PEC and select OK. Now for the third, provide the name, value for x1, value for y1, length x, length y, value of z, and press OK. Now again repeat the same procedure. Provide name, value of x1, value of y1, length x, length y, and z. The next step is to model the feed lines on top of the substrate. Therefore, go to the geometry, select patch, and then a patch geometry dialog box will open. Now provide the transversal coordinates. Again, provide a name, value of x1, y1, value of length x, value of length y, value of z, and press OK. The next step is to model the feed lines on top of the substrate for the other side. Therefore, again repeat the same process. Go to the geometry, select patch, and then a patch geometry dialog box will open. Enter the new set of values for the same and press OK. Values of x1, y1, length x, length y, value of z, and press OK. The next step is to add the ports to the square resonator device, for which the S parameters will be calculated. Each port will simulate square resonator structure that is connected to the structure at the port's plane. Voltage ports are the most accurate way to calculate the S parameters of any microwave device and should thus be used here. To define the port 1, go to the excitation and choose the voltage port. It will open a dialog box. Give the port name and appropriate dimensions to define the exact port. You need to provide the values of x1, y1, z1, then values of x2, y2, z2, provide the value for port impedance and select OK. Similarly, define the second port by providing its values for x1, y1, z1, x2, y2, z2, and press OK. Now we need to provide the value for the Zmax for the surrounding space. After providing the requisite value, press OK. Now we need to provide the value of Zmin in the boundary condition setup box. Open the boundary condition setup box. Provide the value of Zmin and press OK. The next step is the solver settings. For this, go to the solver and by pressing the setup, a dialog box will open. Provide the various settings as per the formula. Once you've provided all the settings, you need to press OK. After doing this, now you need to save the project. For this, go to the File menu and select the Save option. Give an appropriate name. And save. After saving it, now you need to press the simulation button to start the calculation. A progress bar will appear in the status bar, displaying some information about the solver stages. Once it is done, you can review the results